Scientists asked a forbidden question: could an industrial civilization have existed on Earth before humans and left no trace? The geological evidence they uncovered challenges everything we assume about our planet's past. In 2018, astrophysicist Adam Frank and climatologist Gavin Schmidt published a paper that sent shockwaves through the scientific community. They called it the Silurian Hypothesis, named after an ancient race from Doctor Who. The premise was simple but profound. If an industrial civilization had flourished on Earth millions of years ago, what geological signatures would it leave behind? The answer they arrived at was disturbing. After just a few million years, nearly all direct evidence would vanish. Cities would erode to dust, plastics would decompose, even nuclear waste would decay beyond recognition. Earth has existed for 4.5 billion years, yet the geological record preserves only fragments of that immense timeline. The planet's surface constantly recycles itself through plate tectonics, subducting ocean floors back into the mantle every 200 million years. Erosion, volcanic activity, and metamorphic processes erase ancient surfaces. The further back in time, the less evidence survives. Entire eons have left barely a trace. Complex life has existed for roughly 600 million years, but that represents only 13% of Earth's total history. The remaining 87% remains largely a mystery, its secrets buried or destroyed by geological forces beyond recovery. The Permian extinction 252 million years ago wiped out 96% of marine species and 70% of terrestrial vertebrates. The geological layer from this period contains anomalies that puzzle researchers. Carbon isotope ratios shifted dramatically in ways typically associated with massive fossil fuel combustion. Ocean acidification occurred at rates far exceeding normal volcanic activity. Temperature spikes happened within thousands of years, not the millions typically required by natural cycles. Sediment cores reveal trace metal concentrations that mirror modern industrial pollution patterns. These markers appear suddenly in the geological record, persist briefly, then vanish, leaving scientists questioning whether natural processes alone can explain such rapid, coordinated environmental changes across the entire planet. Any industrial civilization would inevitably discover and exploit fossil fuels. Coal, oil, and natural gas represent concentrated energy sources that form over millions of years from compressed organic matter. These resources offer the highest energy return for the technological investment required to extract them. A previous civilization would have burned through deposits that took hundreds of millions of years to accumulate, just as humanity currently does. The chemical signatures left behind would be nearly identical: elevated carbon dioxide levels, shifted isotope ratios, and trace metal dispersal patterns. Within 10 million years, new fossil fuel deposits would form from that civilization's own organic waste, creating a perfect cycle that erases evidence while generating fuel for the next industrial society. Concrete crumbles to unrecognizable sediment within thousands of years when exposed to weathering and chemical processes. Plastic, despite its reputation for persistence, degrades under ultraviolet radiation and microbial action within centuries to millennia. Even the most durable synthetic materials break down into molecular components that become indistinguishable from natural organic compounds in geological layers. Fossilization of artificial materials remains extremely rare, requiring specific conditions that almost never occur. After several million years of tectonic activity, erosion, and chemical transformation, no physical artifacts would remain identifiable. The absence of ancient plastics or concrete in the geological record therefore proves nothing about whether previous civilizations existed. The ocean floor covers 70% of Earth's surface, yet it preserves the shortest geological memory of any environment on the planet. Seafloor spreading creates new crust at mid-ocean ridges, while subduction zones pull old crust back into the mantle at plate boundaries. This conveyor belt system completely recycles the entire ocean floor every 200 million years. Any evidence of coastal cities, underwater mining operations, or maritime industrial activity gets dragged into the mantle and melted beyond recognition. The oldest existing oceanic crust dates back only 280 million years, found in the Mediterranean Sea. Everything older has vanished into Earth's interior, taking potential evidence of ancient civilizations with it. The Carboniferous period, spanning 359 to 299 million years ago, witnessed insects growing to monstrous proportions that defy modern biology. Dragonflies achieved wingspans exceeding 2.5 feet. Millipedes stretched over 6 feet long. Scorpions reached the size of large dogs. These giants thrived because atmospheric oxygen levels soared to 35%, compared to today's 21%. Higher oxygen concentration allowed insects, which absorb oxygen through their exoskeletons rather than lungs, to sustain much larger body sizes. The period also featured vast coal-forming forests that locked away carbon at unprecedented rates, dramatically altering the planet's atmospheric composition and creating conditions unlike anything seen before or since. Intelligence emerged on Earth through radically different evolutionary paths, proving that human-style cognition is not the only route to complex problem-solving. Octopuses, with their distributed nervous systems and 8 flexible arms, manipulate objects with precision despite having no skeletal structure. Crows fashion hooks from wire and use multi-step tools to access food, demonstrating planning abilities that rival primates. These creatures evolve sophisticated intelligence completely independently from mammals, separated by over 500 million years of evolutionary divergence. Their existence proves a crucial point. Tool use and abstract reasoning can develop in forms utterly alien to human experience, raising profound questions about what technological signatures we should expect from non-human civilizations. 2.4 billion years ago, microscopic cyanobacteria triggered the most catastrophic environmental disaster in Earth's history. These simple organisms developed photosynthesis, releasing oxygen as waste into an atmosphere that had contained almost none. The oxygen poisoned nearly all existing life forms, which had evolved in an oxygen-free world. Oceans rusted as dissolved iron oxidized and fell to the seafloor, creating the banded iron formations visible today. Atmospheric composition transformed completely within several hundred million years. This event proves a critical point. Even primitive life can fundamentally restructure an entire planet's chemistry, leaving permanent geological signatures that persist for billions of years. Humanity's industrial age is carving signatures into Earth's geological record that will outlast our species by millions of years. The carbon isotope ratios in current sediment layers reveal a distinctive fingerprint of fossil fuel combustion that differs measurably from natural carbon cycles. Microplastic particles are becoming embedded in rock formations worldwide, creating a thin but persistent marker layer. Radioactive isotopes from nuclear testing since 1945 have dispersed globally, establishing a precise chronological boundary future geologists could identify. Concrete production has altered the chemical composition of sediments near every major population center. These markers, combined with mass extinction rates now exceeding background levels by orders of magnitude, form a comprehensive geological signature that could remain detectable for tens of millions of years. The geological record keeps its secrets well, challenging our assumptions about Earth's deep history. If this investigation into our planet's hidden past intrigued you, like this video, subscribe for more, and share it with fellow curious minds.